Notice this class is about elasticity of demand. One of many classes we offer on this subject, mainly because a lot of students seem to have a problem with elasticity of demand. Maybe it's the language, maybe it's the terminology, I'm not sure. But we offer many classes on it, and this is yet another one. And in this one, I want to talk about how to calculate the elasticity of demand. And to do this, we're going to actually use the Greek letter eta, which looks like a letter N for us, except, and I can't really do it here on the screen, but it's got one leg slightly longer than the other for the N. So it's not quite an N. It's a bit elongated on one side. However, let's see how we calculate elasticity of demand, and after that we can spend more time in different classes talking about what it means, how to use it, when you would want to use it, its advantages, even its disadvantages. So we'll cover all of those things in subsequent classes. So we're going to calculate elasticity, which we'll call eta. Give it the Greek letter. It looks like an N, as I said, but not quite. The one leg is slightly longer than the other. The price elasticity of demand is measured by, and that looks really intimidating. That looks very, very upsetting. In fact, it's easy. Let me put the cursor on the screen, I'll show you. This is our elasticity figure when we calculate it. We haven't calculated it at the moment, so it's just the eta, this one up here. We just let elasticity equal that. It's equal to the percentage, and this triangle here is another Greek letter. This is delta, which means change in. That's how we use it, change in. So you write down the triangle here, which is delta, D-E-L-T-A, delta, and that is equal to change in. Okay, so we have if we read it now, percentage change in quantity. Now put it all together. Percentage change in quantity divided by the percentage change in price. Sounds reasonable? Sounds a lot better than looking at this intimidating expression here, but just read it in English. Go percentage change in quantity, percentage change in price. Okay, so now we've got this idea of what elasticity is. It's the percentage change in the quantity divided by the percentage change in price. So if a good's price changes, the quantity demanded will change, and we work out the percentage change in one divided by the percentage change in the price, and that's it. So that's just stating what I've just said, so just make a note of that one. Now let's consider an example. Let's say that the price of a good increases by 2%, and as a consequence, its demand falls by 10%. So something goes up in price by 2%, and its demand falls by 10% because of the increase in the price. Let's just say that happens. Now we're going to measure the price elasticity of demand, and that's our formula. Our formula is elasticity, eta, is equal to the percentage change in the quantity divided by the percentage change in the price. You see, when you put it into words, it's not bad. It's quite easy. Percentage change in quantity divided by the percentage change in price. Simple. So let's apply it to this calculation. So we've got the percentage change. Now, instead of writing the percentage change in quantity divided by the percentage change in price, let's write out the percentages. So instead of having that, let's just work out the percentages. So we have our formula, and how we work out a percentage is we take the change in something divided by the quantity multiplied by 100. That's how we work out the change, the percentage change in something. You take the change divided by the quantity, multiply it by 100. The same for the price. Change in price divided by the price times 100. That gives you the percentage change in the price and the percentage change in the quantity. So those hundreds can cancel. So now we've got the elasticity is the change in the quantity divided by the quantity over the change in price divided by the price. So we can knock off the hundreds just to make it a bit simpler. And that's what we've got there. So let's write it. Let's get rid of all the clutter here, and we'll just focus in on this bit over here. So let's write that out, and there it is. So now we've got the elasticity is equal to the change in quantity divided by the quantity all over the change in price divided by the price. Right. Just take the denominator here, go back to school days, the denominator, invert the denominator and multiply. We invert it, turn it upside down and multiply. So when you're dividing by a fraction, that's what you do. You turn it upside down and multiply. Imagine this was a 1 and this was a half. We'd have 1, that's 1, a half, or we turn it upside down and multiply. So 2 over 1. 1 times 2 over 1 is 2. So there are 2 halves in 1, which is not a very clever thing to work out. I agree, but it's good fun. So this is our expression here. So tidy it up a little bit more and make it look a bit nicer, and that's what we've got. This relationship here is the one that we use. We normally just tidy up the terms. If you go back to this one, you see I've got the quantity, the price, and what we started with is the quantity, the change in quantity and the change in price over, sort of not under each other. So just put them under each other, makes it tidy. Get rid of this multiply term as well, and we could get rid of that. But for the moment, we can hang on to it. Now, let's do a calculation. In a local restaurant, when the price of coffee was increased from £2 to £3, the quantity of coffee sold fell from 83 cups a day to 71. What is the price elasticity of demand for coffee in the restaurant? That seems a very practical calculation. The price has gone up and they're selling less. Let's put our formula down, and that's our formula. And let's start working it out. So we'll write down our formula again. We know what that is equal to. It's equal to that. We've done it earlier on. And if we take this bottom bit here, and that's a fraction, so we invert it, we turn it upside down and multiply. And there it is. This bit just turned upside down, multiplied, and I've moved the delta P over under the delta Q. We've got P over Q. So just turn it upside down and multiply. So now we've got this term here. We still got this minus sign, but that's okay. Demand curves slope downwards, so you're always going to have a negative sign. Nothing to get excited about, just you can ignore it if you wish. Let's feed the data into here. So we're saying that there's 12 cups of coffee less. The change in the quantity is 12 cups of coffee. Okay. And the price has gone from 2 to 3. And it used to be to sell 83 cups a day. So let's have a look then. Just multiplying that out, we got 24 over 83. So we got minus 28.9. Say minus 29. So it's highly elastic. In other words, the amount of coffee sold in the shop is very sensitive to price. So was it a good idea to increase the price by a full pound? Perhaps they should have just increased it very small amount if they could. Instead of going from £2 to £3, go from £2 to 2.1, maybe 2.2, if they could afford to do that. Because that's a very, very big decline in sales. 28.9. Elasticity, the price elasticity of demand, 28.9. That's significant. So this figure tells us what happened in terms of the change in demand when the price changed. One final point on elasticity. We could do this for income. Changes in income changes demand. We could do it for advertising expenditure. Changes in that changes demand. So anytime there are two variables that are linked in some way, we can work out the elasticity. So the formula can be applied in many situations. Now, this is really an introductory class, so if you're finding this one difficult, don't panic. We'll be doing it again and again and again, and it will come clearer. But I do suggest you go across this one several times, make your own notes, and see if you can figure it out. But as I said, we'll have more classes on this, and by the time you've finished, I think you should be an expert on elasticity. So nothing to panic about, nothing to worry. Just try your best with this one to see if you can work out what I've just said, and we'll go back over it in a different situation as time goes by on the course. Okay, so that seems to be it. Let's leave it at that and say thank you for watching.